I'm John Mittendorf. In this training videotape, we will demonstrate some of the advantages of positive pressure ventilation for fireground operations, and then hear from firefighters who have utilized PPV. Now, as you know, safe, timely, and effective ventilation is critical for the quick rescue of trapped victims and effectively attacking, controlling, and extinguishing structure fires. With the introduction of positive pressure just a decade ago, ventilation took on a whole new meaning worldwide. But today, the use of positive pressure in fire attack has become one of the more important and advanced firefighting tools in the modern fire service.
PPV forces fresh air into a building, creating a pressure force, similar to blowing up a balloon. This pressure will be equal within all pressurized areas of the building. An opening to the outside creates an airflow that forces the contaminants out of the structure. Optimum PPV depends on controlling the entrance opening and providing an adequate-sized exhaust opening. In a typical PPV application, an exhaust vent is created as close to the fire as possible to provide horizontal and/or vertical ventilation. One or more blowers, depending on the size of the structure, are positioned at the appropriate entrance, far enough from the door to create a cone of air, sealing the entrance opening. While electric blowers may be used, today's gasoline blowers produce much more air and are tremendously more effective. PPA depends on teamwork and efficiency. While crew members lay the attack line and position the blower in the entrance opening, another member of the crew, or an officer, makes sure that there is an exhaust vent in the vicinity of the seat of the fire. Securing an exhaust vent may involve opening a door, breaking out a window, or enlarging an opening already made by the fire. Without an exhaust opening, positive pressure's effect on the interior will be minimal. When the exhaust opening and the attack line are ready, the blower is positioned to seal the entrance with pressurized air, usually less than 8 feet away. After allowing a short time for the smoke and heat to ventilate, crews advance the attack line, remembering to spend a minimal amount of time in the entrance opening. The reduced heat, smoke, and improved visibility enable a swift, efficient attack on the seat of the fire. The resulting steam and products of combustion are carried away from the attack crew and exhausted to the outside. When the fire has been knocked down, the blower continues to improve the interior environment in the structure, making it easier to determine the fire cause and conduct overhaul. After knocking down the fire, begin thorough overhaul in a timely manner. Positive pressure can overcome signs of hidden fire by reducing heat and smoke. Positive pressure, when used correctly, does not normally spread or increase the size of the fire. In test after test, burn after burn, PPA continues to provide a safe environment for firefighters to enter a burning structure, forcing heat, smoke, toxic gases, and other contaminants away from the firefighters as they enter the structure.
Most fire departments use PPV in the overhaul process after the fire has been knocked down. Now, while that's effective, today's more advanced departments use it in fire attack operations with outstanding success. However, PPA operations can be much more effective with a combination of proper equipment, training, and safe practice techniques.
With the cooperation and assistance of the Salt Lake City Fire Department, we used these buildings to demonstrate the process. There were 4 two-bedroom homes with the same floor plan. They were approximately 1,100 square feet with a kitchen, eating area, and living room. Each had a basement. There were 2 entrances, the front door and the side entrance, which led directly to the basement or into the kitchen. Here are 9 guidelines to ensure PPA's proper and effective use. 1. The crew should have a thorough knowledge of fireground ventilation practices, including positive pressure ventilation. If you don't understand how PPV works, get appropriate training before using a blower on a structure fire. 2. Attack line should be in place and ready to advance to the seat of the fire as ventilation begins. 3. Backdraft conditions must not be present. 4. The exhaust opening should be as close to the seat of the fire as possible. 5. Pressurized air from the blower or blowers should seal the entrance that interior crews are using as completely as possible. It's important to use a blower with a shroud. Caged blowers can pick up loose debris, creating a safety hazard, and they don't seal the opening as well. 6. One blower provides acceptable pressurization for most single-family dwellings, but 2 inline blowers will provide better results. You'll get more CFM and pressurize the structure faster. 7. Advance attack lines inside a few seconds after the blowers begin running. Give the blower or blowers time to push the smoke, heat, and gases away from the opening. It'll improve visibility tremendously. 8. Crews should keep out of the entrance opening during the operation so they do not block the flow of air. 9. Use either horizontal or vertical exhaust openings, but give horizontal openings first consideration as they are quickest and easiest to open, which reduces implementation time. In the first evolution, PPA is used in a fast attack operation without a hydrant and with a staffing of 3 or 4. The first arriving apparatus at the fire scene attacks the fire with PPA and a 1 3/4 inch line supplied by tank water. The officer assigns tasks, notifies crew and incoming companies of the decision to go in on fast attack and lay a supply line. He advises the hydrant blower firefighter on the placement of the blower. The officer informs the nozzle firefighter on which 1 3/4 inch pre-connect line to pull. The officer grabs a forcible entry tool and sizes up the building. If necessary, the officer makes or improves on a horizontal vent at a location near the fire, then assists with the attack. The firefighter in charge of the nozzle pulls the attack line as directed by the officer to the entrance of the building and helps gain entry through the entrance opening. The driver operator sets up the apparatus and charges the attack line.
The firefighter responsible for the hydrant blower secures the blower and a forcible entry tool from the apparatus, extends a handle, and then wheels the blower to the point of entry as directed by the officer. The firefighter starts the blower, and when the attack line is at the entrance and ready, the blower is positioned properly back from the entrance opening. The firefighter with the nozzle and the officer begin the fire attack after the blower runs for just a few seconds. The fire is attacked and knocked down quickly. Afterwards, this is what the attack team had to say about PPA. Okay, in your opinion, what did PPA do for you on this last scenario on the single-family dwelling?
Well, in the house was charged from the time we entered the house, and within seconds it cleared it out so we could walk right to the seat of the fire. So visibility is a big thing. Also, removal of heat, allowing us to get closer to the fire for the attack, is a big advantage.
In your use of PPA, what do you think PPA has done for you as far as enhancing fireground operations as compared to before you were using PPA?
Well, like I said, visibility. I mean, that's one of the biggest, the hardest things we have to overcome is not being able to see. So if we can see, we can attack the fire faster, also perform search and rescue better, and anytime we can remove heat from the atmosphere, making it safer for us, those are two big advantages.
What do you think PPA did for you in this fire attack?
Well, in this scenario, it greatly enhanced the visibility, as my partner was saying. We went into the house, and within seconds we were able to see all the way down the hallway, visualize the fire room, visualize the fire without worrying about visibility. That would enhance not only our fire attack, but any type of rescue situation where we had to get to someone who was trapped inside.
Bottom line, do you think PPA has a tendency, or does it enhance safety in fire attack operations?
I'd say based on this, yes, absolutely.
As the company officer, what did you notice that the PPA, or how did the PPA affect the fireground environment on this scenario?
Well, when we went into the building, we had a lot of fire. It was also going over our heads. Normally, the heat in that situation would be extreme, and I would have a hard time advancing my crew through that fire. Visibility was somewhat diminished to start with. It got better, but there never was the heat. It made the attack a lot easier. It made the overhaul, when we started doing that, a lot easier. We were able to see a lot more. Where there was still fire in the attic and the ceiling we had to pull, it was very easy to see it.
Some people feel that positive pressure has a tendency to make a fire larger or enhance the size of the fire, make it more intense. Did you notice that in this scenario?
Like I say, when we went in there, we had a lot of fire. It went out fairly quickly once we got to it and hit it. I think it made us getting to the fire easier, so I would have to say it helped our cause.
Have you used positive pressure on overhaul operations during your career, and what have you noticed that it's done in that area?
Well, after the fire's out, it's a lot harder for people to realize that those chemicals are still in there, so it's easier to get hurt. It helps clear those chemicals out, the hot gases, and it makes the whole job of overhaul go smoother and quicker with less effort from the men.
When working with a hydrant, the first arriving apparatus at the fire scene takes the hydrant using its prescribed procedures. The officer has the same duties and responsibilities for sizing up the structure as does the nozzle and driver operators. The hydrant blower firefighter charges the line on command and then proceeds to the apparatus and secures the blower and entry tool. They attack the fire with PPA using an appropriate attack line. Poor ventilation has always made fighting basement fires problematic. PPA can be effectively used in these situations. There are several ways to ventilate basements. If it has windows, even small ones as in this scenario, PPV may still work well. When there are no windows, or if more exit area is required, you can ventilate by cutting a louvered hole as was done here. The fire was in one corner of the basement. Firefighters cut a hole in the living room floor near the front door. They opened the front door, started the blower, and ventilated the basement easily.
Joel, you had the nozzle going down the stairs. As I was behind you, third person back on the hose line, there was a lot of fire wrapping up the stairwell and over our heads. I kept expecting you to open the nozzle up and sweep the overhead as you were moving down toward the landing. You evidently weren't feeling a lot of heat?
No, I wasn't feeling a whole lot of heat. I wanted to get down as far as I could down the stairs before I opened up the nozzle to avoid steam burns to the crew and a lot of steam banking up. So even though there was fire overhead and to the sides of us, it wasn't too uncomfortable, and I was able to get down quite a ways before I felt like I needed to open the nozzle to protect us.
Okay, so you made it to the landing, made the bend into the room, and then blackened the room out. How was the heat as you moved into the room to blacken the room down?
Pretty comparable to the heat when we were going down the stairs. It was warm, but it wasn't unbearable, and we were able to get down in there and just open up the nozzle a couple of times and blacken it down right away. So the heat wasn't really too much of a factor.
Okay, yeah, I was in the room just shortly after it was blackened out, and the captain and I were standing up in the room. Visibility was still pretty limited. It was starting to clear out, but we were standing up. There was not enough heat to keep us forced down at that point in time. So,
successful PPA depends on a number of factors. Besides a knowledgeable attack crew, the type of blower and the ventilation opening are important. A powerful blower that produces a large volume of CFM is needed, but it's possible to have too much CFM and overpressurize the structure. Therefore, CFM is not a blower's only criteria. A blower with a shrouded 21-inch diameter impeller powered by a 5-horsepower gasoline engine is usually the minimum size blower to be used for PPA. The weight-to-size ratio of this unit allows maximum airflow, yet the blower is small enough to fit in apparatus compartments and allow one firefighter to position the blower. Shrouded blowers create a cone that seals the opening, preventing smoke, gases, and other contaminants from being pushed back over the top of the blower and endangering the safety of the attack team, who are about to enter the structure. Tests have shown that a shrouded unit, as compared to a caged unit, also creates a unique pressurized air pattern that is more conducive to velocity at the exit point. The ventilation opening is another critical positive pressure factor. Too large an opening does not allow the structure to build pressure. Too small an opening will not allow enough smoke and heat to escape and can trap CO in the structure. Exhaust extension tubes can also be installed on the blower to nearly eliminate CO buildup during overhaul or CO response calls. In most PPA situations, creating a horizontal opening is fastest, but there are times when vertical ventilation may also be needed, even preferred. Vertical ventilation creates a chimney over the fire, allowing the smoke and deadly gases to exit up and out. Vertical ventilation greatly reduces interior mushrooming effects of smoke and heat. Vertical ventilation openings are also used as directional holes, cut ahead of fire to stop its horizontal spread by allowing it to vent vertically instead of mushrooming along open spaces. Vertical ventilation should be used if backdraft conditions are present. Vertical ventilation works well with positive pressure. There are a few key guidelines when cutting the hole. Work as quickly as possible and leave the roof immediately when the work is finished. Do not cut deeper than necessary to get through the roof material. Always cut away from the fire and towards a means of egress. Start ventilation cuts in the portion of the roof nearest the fire and finish away from the fire. When possible, work on the windward side of the ventilation hole. Do not hold the saw in line with the body in case of kickback. Know the roof construction and verify the location and direction of structural roof members. An effective fire attack is the result of planning, training, and knowledgeable decisions at the scene. Choices made at every level of the command structure, from the incident commander to apprentice firefighters, can have a huge influence on the outcome of a fire. The use of positive pressure ventilation in a coordinated fire attack operation is clearly one of the most advanced firefighting techniques in use today.
Chief Garcia, how did the Salt Lake City Fire Department get into or start using positive pressure ventilation?
Well, about 9 years ago, we had a class in positive pressure ventilation from a gentleman. We didn't believe it, and we set out to prove him wrong. And the more we tried to prove him wrong, the more we were proving him right. Nothing kept happening, but things got better and better as we tried it. Went to the point that we started putting them on our engines, first line apparatus, and then we asked the question that if ventilation is truly a coordinated attack, how can a truck company arrive at the same time and have a process that's probably 5 or 10 minutes longer and actually vent ahead of the attack crew and have a coordinated attack? And we had a challenge doing that. Have developed an SOP where 4 folks can use it, get off and place the fan without adding any time to their attack. They're carrying their ventilation with them. They're doing it in a coordinated fashion. They're rescuing folks prior to them even finding the people that are in need, because they're blowing fresh air and oxygen and cool air to where the folks are.
Hey, Chief Garcia, the Salt Lake City Fire Department has coined the phrase PPA, positive pressure attack, which sounds a little bit different than PPV, positive pressure ventilation. How does positive pressure attack, PPA, differ to you and your operations than positive pressure ventilation, PPV, would to somebody else?
Positive pressure attack, just in changing the name of it, changed our philosophy that is something we do as an attack. We feel very comfortable with using the fan first thing right with the initial hose line, as long as when the fire's in the free burning stage. We have no reservations. It's cut. When the term positive pressure ventilation was used, our truck companies we'd wait for them to get there with their fans and set them up. We'd wait for another engine to bring their fans. Folks never thought that they could combine and tactically ventilation and attack at the same time. So we changed just the wording of it, developed an SOP to support it with either 3 folks, which would be a 4-handed engine, 1 person taking a hydrant, or the 4-handed operation where they're actually the first-in companies taking their own ventilation with them. Had tremendous results.
Now, you mentioned that Salt Lake City Fire Department has used PPA, positive pressure attack, for approximately 9 years. Some people feel that positive pressure has a tendency to enhance or make a fire larger, more intense, intensify the fire. Have you found that to be true in your operations?
We haven't, and we didn't know how to answer that question when we were first asked it. But in working with it over the years, we've come to the realization that if the fire is in a free burn state, it already has 16 to 20% oxygen. If I put in more 20% oxygen, I'm not doing anything than just maintaining a free burn fire. The intensity, we've put the fan intentionally in the wrong place. We put the fan where the fire is and tried to blow it throughout the house. Funny thing is, the fire usually gets smaller and it never transmits anywhere. The application and the practice of positive pressure ventilation and positive pressure attack has to be, because the folks have to realize it's a volume operation. It's an operation where we're not putting velocity in the structure more so than we're just changing the atmosphere gently inside that structure to more than push push stuff out to displace stuff, displace the combustibles and the products of combustion with cooler, fresher air.
There's no question the PPA can improve fire attack operations by putting fresh air at the back of an attack team as it enters the structure. You've seen and heard what firefighters think and say about it. It drives the heat, gases, and smoke away from them and can reduce the fire's intensity. Now, as a result, fires are knocked down faster with less water damage to a structure. Additionally, it also greatly improves visibility and makes finding trapped victims easier. It all adds up to enhanced safety on the fire ground.
You can order the video you've just seen, Positive Pressure in the Fire Attack, direct from Tempest. It's just $89.95, including shipping and handling, and your credit card is welcomed. Call Tempest Training Division at 1-800-346-2143 or visit Tempest's website at www.tempest-edge.com. Do you want to learn more about positive pressure in the fire attack? Do you need new materials about PPV or PPA? Are you interested in the availability of PPV and PPA training classes by John Mittendorf? Call Tempest Training Division for complete details. Tempest also offers the most comprehensive PPV training system available today. It is an integrated curriculum created by a university professor that covers both basic and advanced techniques. There's step-by-step instruction for both instructor and students. The system includes everything your department needs to begin teaching PPV. It's just $395, and that includes a copy of this videotape. Call Tempest today for more information or visit our website.